Hey everyone. In this part two, we're going to go into a little bit more details about the double water drip. And to get you going, I thought I would just show you some pictures of double water drips that I've done in the past. I've been doing this for about 15 to 17 years or so. Actually met up with Martin Waugh, who is the originator of this. Super nice guy out in Portland, Oregon. And if you really want to see some killer water drips, you should check out his site. I think I'll put a link in it somewhere in this video in the end. Um, so here's some of the water drips that I've done in the past. And it's two things in particular. One is really getting the lighting right. And the second is once you dial in time, you can really take hundreds of pictures like this in a sequence. The focus is also pretty tricky. And you can see the focus here. I don't have, there's a cursor. You can see the focus here is on that front edge. And typically we'll try to get that first third or so in focus and use depth of field to try to get almost this front lip in focus as well as a little bit back. Uh, so here there's a picture. There's actually a real flower in the background here. And the flower is lit with just a little bit of light on the actual drip itself. It'd be nice to get a little bit more focus in this, but I think this is one from about 12 years ago or so. It's kind of fun. Let's see what else we got. A little bit earlier in the collision, I'm moving the flash time to a quicker time, or earlier in the collision, and you get a flatter pancake kind of splash pattern. And they're all kind of different. They really are similar to snowflakes. You really never get the two effects or two splashes identical each time. There's an infinite number of lighting. Here I used some flashes, I think, below the water with gels on them. The viscosity of water also changes with the temperature. So the colder the water, the higher the viscosity of it. So it's something you might want to try out. It turns out if you put ice in the water, you'll probably get it the coldest, and some nice effects there. Multicolored backgrounds again. Here, this is a little bit off axis of a splash, and it's a pretty nice pattern. All of the pictures are really fantastic. So it's hard to sit down and look at several hundred of these pictures and say, oh, these 4 or 5 are the best. So these are ones that I particularly like. So let's look at the code and see how the code works out for this when you're looking at an Arduino code. I am going to go through the code. Okay, let's talk about the code here and what's going on with it. So this code has been published in a few other places, including Petapixel and a couple of articles on the web. It's pretty straightforward, so I'll go through it. I'm not going to retype it or anything. The big idea about this is we're going to use a bunch of variables at the beginning of the program that we're going to change if we have to. And they typically, we do change them a lot as we adjust the code. So the first one is the open time. And this is how long the solenoid is open to keep one beautiful drop being created. So this 57 milliseconds here works today. But if it's colder, if the pressure changes, those valves can be off. And you'll have to retune this, and it could be 5 or 6 milliseconds, depending on what the conditions are. The next part of this is a double drip delay, which is the time between the two drips. This is also dependent on the behavior of the drips and the speed of your read relays and stuff. Remember, I'm using 5-volt read relays that are able to switch up to 1 amp, but it takes 5 volts to control them. So they're just perfect for Arduino logic. Here's this splash delay. And this tells me how long to wait after the drips are made to set off the flash. So if I change this, I can get images of different parts of the flash, which is really one of the big variables that we want to play with. Here's an LED that follows the double drip or the solenoid, and that's usually for debugging, and it's nice to know that the solenoid is working right. Of course, if your solenoid jams, you can use a little wire to free up the valve in it. it probably will jam a couple times. Keep in mind, you don't have to do water, you can do milk. And if you switch to different liquids, all these values will have to be adjusted for those different viscosities of those liquids. Keep in mind, if you use anything else besides water, drain your valve after every use. Otherwise, it will clog up. Milk makes a really good paint. So clean everything out. Here's my button pin, pin 2, which is going to trigger everything. It's a constant input. Drip pin, pin 8, flash pin, pin 9, camera pin, pin 10, flash trigger pulse. This is a 3 millisecond pulse that we're going to leave the opto isolator pin high. So the opto isolator is going to jump high, stay high for about 3 milliseconds, and then go back down. And that makes a nice little pulse to trigger most flashes on. And that's why we keep it up for 3. Probably 1 works, just 1 milliseconds would work just fine for that value. But I kind of leave it 3, which covers almost every flash I've ever run into. This last value here is the settle time. How long do we let the water settle for? In this case, 3 seconds. You might want to let it settle longer. If you want little waves to get multiple effects, you might want to change this value lower. When those drips come down and hit those little waves, each drip is different. Here's my pin modes, standard stuff. Input pin is my button pin. Everything else is an output pin. Here's a serial. I left a little serial begin down here, and that's nice to have for debugging, especially if you're a student that's relatively new to coding. You can print out variables that you want to know what the heck they are, if you got them right or not. Here's the meat of the program. It says my button state is now defined as whatever is read from that button pin. And if that button state is high, if the button has been pressed, it's game on and program starts to run. So this first block turns on the valve and makes one really nice drip. That's at open time I can adjust. And there's an LED that follows the action. This delay right here is the time between the double drips. So that's the variable in there. I'll go to the top of the program and change that double drip delay to change that time. This is exactly the same as the first part of the drip code. The drip above, the 1 drip up here, waited time, 2nd drip down here. They're identical drips. I turn on the valve, wait a little while, turn off the valve. Once that valve is turned off and that 2nd drip has been created, I'm going to turn on the camera. Camera's on bulb mode. Turn on the camera. Now I'm going to wait a while. My splash delay tells me I'm going to wait until I set off the flash. And these 3 lines of code here set off the flash. The flash pin goes to the op amp, goes high. On the other side of the op amp, it's connected to the flash. So it triggers a flash, waits 3 milliseconds, shuts the flash off. By then, the signal to trigger the flash has already been taken. Last thing down here, digital write, camera pin low, turning off the camera. And the very last line here is we're going to turn off everything, and everything's going to be on hold as we delay this settle time. It means just wait for the water to settle, and that's that. So nice, simple, fun little piece of code, and a great piece of code for learning control of cameras and a high-speed event like the double water drip.
Okay, let's talk about some close-ups. The lighting is pretty bad right now. I've got the sun coming in one of the windows of the studio, and I don't have a good diffuser for it. But this is the 12-volt battery. It's an old motorcycle battery, and I've got it just sitting around the lab. But it's really convenient, and it is a lot stabler than a lot of other power supplies. So it's nice and easy to use. Here's the Arduino. It's hooked up to the computer right now. So the way the 12 volt works is it comes in through this blue line right here to the read relay. And once the read relay engages, the current is going to leave through this wire here. and engage the relay and then come back. This can be energized. We can kind of hear it, that double little drip as it goes. The push button here is not super happy. I should reset it into something that's a little bit more stable. But the other thing here is this: a few milliseconds after this read relay is finished clicking and making the double drip, the shutter is engaged, and this shutter read relay turns on the bulb shutter on the camera and opens it. Then we wait a time, and this opto isolator triggers the flash. The idea with the opto isolator is it keeps all of this circuitry here free of connecting to the expensive flash triggers. There's probably other ways of doing it, but this is a pretty straightforward and very quick way of doing it. I also have a diode here, an LED, that gives off a flash. It turns on whenever the drip is turned on. So it's just a way of knowing that the dripper is working, and a great way of showing that. So this is pretty much all of the stuff here, and it's kind of a nice little circuit. Okay, here's our little water reservoir. You really don't use a lot of water when you're just doing drip by drip. Here's the solenoid, the 12-volt solenoid valve, and here is a diode, and that diode is bridged from the negative side to the positive side. And that might seem like an odd way to put a diode, but this diode here is used to quench the reverse EMF that's generated in this coil. Basically, it helps the coil collapse faster. You probably don't need it if you're just messing around, but I'm really tired of all the details getting me in these labs, so I have the students put these diodes in, and that seems to help a little bit. So here's a top view of that little pan of water. We'll trigger the double drip, and you can see how it hits that pan real time. If you do this for a while, you get to the idea that, oh yeah, that's a double drip. But I think it's taken me about 10 years to get to that point where I can just tell by looking at them exactly what's going on.
So welcome back. What we're going to do now is just do some shooting. I have a Einstein flash hooked up to the Arduino and through the optical isolator to isolate the Arduino electronics from everything else. And I have a Einstein flash, which I'm using. I'm using a Canon Mark III, and I'm a 105 macro lens with a Sigma, and I'm working at f/18 at ISO 500, and I'm just going to record the JPEGs in this, and we're going to see what the variation is. There seems to be a lot of variation this afternoon. I've got everything in a big tent over there on the side because it's pretty light in the studio. And we're just going to hit this button a bunch of times here and see what kind of shots we get. There'll be a little bit of variation. So here they haven't collided yet. We can see a little air bubble stuck in this top drop as it comes down. Everything looks really good, although the timing is just a little bit early. So I'm going to do 10 shots, see where we are, and then adjust the Arduino if I have to. So here's my next shot. They collided halfway through. And this is the fun part about this work. You're never exactly certain what you're going to get as those images come across, which is really surprising. It's really one of the great things about photography with high-speed stuff. So here we go. Oh, we're really early. Our second drip is not even in frame yet. So this is kind of unusual that it's this much variation in the setup. And here it's already hit. So this is still early for that splash. I really want some more time in that splash. So, okay, here's a little bit later. This is the variation, and I can't really explain this variation, but it looks like it's about 20 milliseconds of variation, which is a lot for this system just to just be sitting here. But it's also pretty warm. It's probably about 80 degrees on this back porch, and it's much different than it was earlier at about 68 degrees because I tuned up everything. Still hits. I'm going to say that my timing is still on the early side most of the time. Still hasn't hit. Wow. So I'll share the screen with you guys, and I will go and hit this Arduino. This is the delay here, this splash delay, and I'm going to bring it up to about 260. So that's after that second drip is formed. It's going to wait that amount of time before it sets off the flash. So let's go back to this EOS and trigger it again. And it still looks like it's still going to be early for us. We'll do a couple and see where we're at. This is still pretty up in the collision. Nice collision though, nice pillar. We should be able to get a little bit later on this. So we can let the variation in the system, see if it'll give us a nice picture, and then we'll see where we're at. If not, I'm going to change the speed. This is what I like to call a top hat pattern. This drip is still going up. The second one has just hit it. This would be a real nice curtain in a few milliseconds later. Let's keep going. Oh, hey, that's nice. We're using orange here today, by the way, because orange is school colors. It's RIT. Even though we're working from home these days, orange is the RIT colors. So there's a nice little split sheet on the top. I'm going to say the focus is not bad. I'm going to leave it alone. Let's keep going. Oh, hey, nice. So this is a sideways splash. A lot of variation in this. Let's keep going. Seems maybe it's stabilizing out. I'm not sure. Nice sideways shot. So this is typical. Once you get the system all set up, this is pretty typical for what you're doing. You're going to go like this for thousands of shots, and you're going to be looking for some great artistic statement in water drops. What that artistic statement is, I'm not quite certain, but it's really just a heck of a lot of fun doing this, and you can really see why people all over the world have taken this on as a kind of a fun art project, as well as a really great learning example for high speed stuff. Oh wow, that still hasn't hit yet. Close. Hmm. Okay, so a lot of these are still really early collisions. So what I'm going to do is I'm going to pull the code and time it back probably about another 5 thousandths of a second. And we'll go back to this and we'll take another one, see where we're at. Okay, a little bit later. Okay, looking cool. Maybe we can get one of those nice even splashes right towards us. Okay, it's pretty far down in its splash. Well, there's a nice pillar, nice flat collision. sideways one. Very, very common. They just don't hit dead on. Oh, there's a dead on one. Little bit late in the collision. Might want to bring that back a couple thousandths of a second, but it's still looking pretty good. Wow, that's a fun one. And away we go. I mean, how many hours do you want to do this for? Not super happy with the lighting, but it's a good demonstration of what's going on. I could put some nice flowers back there and light the flowers, and it'd probably be a lot better. So it's a pretty good area. The timing is pretty good. The valves are pretty good. We're getting lots of variation. Little hat pattern there, and there's an off-axis hat pattern. Kind of a nice one. A lot of times you're like, wow, that's great, but I'd like it rotated like 90 degrees or tilted just a little bit. Well, that's pretty good. I'm going to stop there. You get the idea that once you're in the zone, as this is adjusted here, you could just shoot for hours and hours and hours, and it's really a fun thing. Hope you enjoy this project. Have some fun with it. Build your own and shoot to your heart's content, because it's a fun thing to do. And take care.